Hi KubeCon and welcome to the NetApp booth. My name's Nigel Poulton. I am the author of the Kubernetes book. I've got a bunch of online video training courses on anything to do with cloud containers and most certainly Kubernetes. And I'm actually super excited to be here today at the NetApp booth. Got a pretty sweet demo with some of the stuff and some of the integrations that NetApp are doing with Kubernetes. So the demos that we'll see today will be pretty cool, but I've got to tell you, and we'll talk about this maybe a little bit at the end, it's only the start of some great things to come from NetApp in the Kubernetes space. Now, I'm super pleased to be joined by Bala, who is one of the technical gurus that I talk to at NetApp, so he's going to keep me straight on this. Bala, do you want to just give everybody an introduction to yourself?
Hey everyone, welcome to KubeCon Europe. I hope you're having a good time with it being a virtual event. I am Bala Ramesh. I am a technical marketing engineer who works with all of our container solutions at NetApp. I specifically work with a product called Trident. In case you haven't heard about it, it's our dynamic storage provisioner for Kubernetes environments. And this demo will be taking a look at how you can use Trident in conjunction with NetApp's storage services to provision persistent storage dynamically for your Kubernetes environment.
So just real quick, Bala, with regards to any sort of storage solution that wants to be Kubernetes native, the CSI driver is really at the heart of that, yeah? And for NetApp, that CSI driver, just for anybody who may not be aware at the moment, is called Trident, yeah?
Trident is much more than a CSI driver in itself. You need to think about it as a solution that makes it possible to communicate with a whole range of NetApp devices. So ideally, we're looking at 10 unique CSI storage drivers that can communicate to a whole host of NetApp storage solutions, whether it's ONTAP, whether it's SolidFire, Element, or something that's on-prem or in the cloud, right? You have a single point of contact, one single package that runs as a Kubernetes application and helps you consume storage for your Kubernetes environment, no matter where you choose to run it.
Right, so with Trident, we can hook a Kubernetes cluster and any applications running on that Kubernetes cluster to pretty much any NetApp-based backend. So ONTAP stuff, SolidFire stuff, and we're going to show in a demo today NetApp CVS Cloud Volume Service in the Google Cloud, yeah?
Exactly.
So I've said quite a lot in the past that I really feel like we're a long way off having good management of stateful applications and persistent data in Kubernetes, or at least like enterprise grade management of that data is what I've been looking for a long time. Now, NetApp with Trident has been out there for quite a little while now, actually, and I'm super stoked to see that, you know, a trusted enterprise partner like NetApp are playing in this space. They've got you know, a strong presence in the CSI space, but like we said, it's only the beginning of more things to come, yeah?
You make a fair point. In the past 2.5 to 3 years, where we have seen a host of Trident releases, we have evolved from all versions of Kubernetes, beginning with the earliest CSI support that was introduced with 113 to all the way up to 118, and once 119 ships, that's also going to be supported. And like you say, CSI is changing the way how we could standardize, think about storage as a community-based effort, right? And NetApp is in the heart of this open source community support, and Trident is a free-to-use and fully open source solution that's completely supported by NetApp. So like you say, in today's demo, we will be taking a look at how you can use Trident for a GCP environment, but that's just scratching the surface, so to speak. You can do a whole lot more, and there's a lot more good stuff where this came from.
Magic. Okay, so speaking of the demo, let's take a look at what we're going to build here, right? So I mentioned we're going to be on the Google Cloud, but it does not have to be on the Google Cloud. Other cloud platforms are supported, and we've mentioned on-premises things as well, ONTAP, SolidFire, things like that. So we'll go with the Google Cloud. We will have some NetApp-based storage on the Google Cloud called Cloud Volume Service, CVS. We'll take a look at what that looks like and maybe what the sign-up screen looks like in a second. But once we have that, we'll build a Kubernetes cluster. Now, an important part of building that cluster, as we'll see, is we need to make sure that we build the right type of nodes into our cluster. So nodes that have the required NFS tools and utilities to be able to connect to this NetApp storage. Now, once we've built the cluster, which is kind of the easy bit, actually none of it's hard, and I was quite surprised at this, but once we've done that, as we can see on the screen now, there's quite a bit of sort of NetApp intelligence that will then be deploying onto our cluster. So some container storage interface stuff, some CSI stuff that we touched on already, but some custom resources and other things that will allow this NetApp storage, which is not part of our Kubernetes cluster, but will allow it to look, smell, and feel as if it is. So we'll be able to use, you know, standard Kubernetes YAML files and things like that to be able to deploy and manage and manipulate that storage. So when we come to build this, we'll be throwing a few kubectl commands around, deploying from manifests and things like that. And when you look at the slide right now, and when you see some of the commands, you might think, actually, this is maybe a little bit more complicated than I bargained for, but it's really not, and we'll talk you through it. And the thing is, what you need to remember is this kind of initial configuration, it is almost a one-off. Once that's in place, it's then literally just deploying your Kubernetes applications, leveraging those constructs that Bala mentioned there, storage classes, PVCs, PVs, things like that. That is bread and butter Kubernetes stuff. It's super simple once we've done the deployment. Anyway, we'll deploy a bunch of NetApp intelligence, I'll just call it that. Then let me just move this screen for a second here. We will, at that point, deploy a storage class, which will be, connected to all of this NetApp Trident stuff. Now, once that's in place, that's kind of the legwork or the hard work done. We'll just deploy a simple MongoDB-based application. We'll assign it some storage via that storage class on there, which will eventually pull the actual file storage from the NetApp, which is going to be running on the Google Cloud Platform, but not part of our Kubernetes cluster. So let me see if I can fix this up at the top somewhere. Maybe, yeah, there we go. All right, now I'm going to switch away from the slide right now. I'm just into my browser. Now, one of the first things to be aware of here, okay, is that in order to use NetApp's Cloud Volume Service, and again, we're just on Google Cloud here, but it can, you know, we can run it on other clouds as well. You do need to sign up for it. As we can see on the screen, I signed up for it a few days ago. Once you're signed up, though, it's fully integrated into the Google Cloud Console. So if I now go manage, so as we can see now, I'm still in the console for my Google Cloud account here, and I've got a number of volumes here that are provisioned on the NetApp CVS backend. So these are file-based volumes. We can see different versions of NFS, the way they're exposed here, all on my Google Cloud Platform, and therefore available to any applications that I run on a Kubernetes cluster on this cloud platform, as long as I use the CSI Trident driver. Now, Bala, I don't know if you want to say anything at the moment about NetApp's Cloud Volume Service and what it offers potentially over and above the normal kind of storage you might get from your cloud provider, maybe where it might differ from ONTAP or something?
So you made a great point earlier, Nigel, when you mentioned that this is a GCP native service. You don't have another portal or another window where you need to manage CVS for GCP. It's all integrated into your Google Cloud Console. We're also talking about highly performant storage that is readily available depending upon how you want to use it. In our benchmarks against applications, we have seen that this performs above and beyond pure native cloud storage offerings that are provided by a respective hyperscaler. CVS is available for both GCP, for AWS, and for Azure. It's called Azure NetApp Files. And we're talking about Trident being able to interface with all the services that I mentioned here. So wherever you choose to run Kubernetes, you have one NetApp service that you can subscribe to by using Trident. And the best part is, with the way how Trident interfaces with these services, you are able to keep track of your storage both at the Kubernetes level and at the storage level using your Google Cloud Console as example.
So what I love is, and what you pointed out there, is that this is NetApp storage. So storage I can trust from a trusted enterprise partner that I maybe have at my organization already. It's it looks and feels just like it's part of the Google Cloud Platform, okay? But later on down the line, as we build a cluster, it's going to look and feel just like it's part of that Kubernetes cluster as well. So like almost end to end, it's seamless. And aside from the performance and all that kind of stuff, it just feels like it's part of Kubernetes, right? Which we'll get to.
Exactly.
So speaking of a Kubernetes cluster, if I just open a quick new tab here, and I will go into Google Kubernetes Engine, and I'm just going to build a new cluster here, because there's at least one thing that we need to be aware of when we build this cluster. Again, it's not something difficult. We just go, as we normally would, create a cluster. I'll call this one, doesn't really matter, we'll call it, not Nigel, we'll call it NetApp. I will just go for a normal zonal cluster, and because I happen to be in Europe and it's KubeCon EU anyway, let's go with Europe West 2B. You know, pick your poison or choose your poison when it comes to which version of Kubernetes you want. I'll go with the release channel in 1.16. I know that that works for sure. The interesting thing is, though, come over to the left here and take a look at your node pool. Within the default pool, I'm just going to click nodes. Now, instead of going for the container optimized storage image, this is going to, so we're going to build a 3-node Kubernetes cluster here. And instead of those 3 nodes being based on the standard container optimized storage, we'll go with Ubuntu here, because as we can see, it has support for NFS. So this will deploy 3 Kubernetes nodes based on Ubuntu 18.04 at the moment, but that has the required NFS packages for us. Now, once we've selected Ubuntu up there, we're ready to create the cluster. I will say just one thing. The setup that we're going through will just be using the default network. If you don't use the default network in your environment, there's some configuration you can do later on, but we'll just build our cluster as it is right now. So normally this is going to take a minute or 2 to build the cluster. So while that builds, actually, I'm going to jump quickly over to GitHub here. So we can just go to github.com/netapp/trident. In fact, I believe this is what the page looks like. It has all the resources that you need here. I'm going to, well, I would just normally click the latest version, take us to 20.07.0 at the moment. Actually, we will be deploying from this version, to be honest. This is a newer version than what I've been working with, but it's just a case of coming down here, download the zip file here, and within that zip file has all of the Kubernetes YAML files and things that we're going to be using to deploy that NetApp Trident intelligence to our Kubernetes cluster. Now, when you download it yourself and unzip it, you'll get a bunch of different folders with all the different resources in. When I run through the demos, I've taken the particular files that I need and we just have them in one simple directory. Just makes the demo a little bit easier. But when I say, when you extract this zipped file here and you get a bunch of different folders, there's not a lot, so it won't be hard for you to find the files, the config files that you need. So it's literally, it would just be click that file there to download it, unpack it into your working directory, and you have all the files there that you need. So yeah, that's github/netapp/trident, and you'll be away. Now let's see where this cluster is up to. Okay, so the cluster is deployed now. We won't go too much into how to operate the Google Cloud, but I just click the connect button here. I'll copy this command and I will paste it into my terminal. All this is going to do is it's going to connect the kubectl Kubernetes command line tool to my new cluster. That looks good. So if I go kubectl get nodes, we should see a 3-node cluster. And just to be sure, I'm going to say kubectl get stateful sets, and there is currently nothing deployed into our cluster. So at this point, we have a brand new Kubernetes cluster on the Google Cloud Platform. Now, we have NetApp CVS configured also on the Google Cloud Platform, but there's nothing connecting our Kubernetes cluster to that NetApp storage service at the moment. So that's what we're about to do now. Now, within this folder, I have got the files required to build that NetApp Trident intelligence into our cluster. So I think the first thing that we're going to deploy here is we'll deploy from this YAML file. I'm going to quickly flip into VS Code and we'll take a look at that. So this file here is going to deploy this particular custom resource to our cluster.
So here, what we're going to do, Nigel, is install Trident as an operator in the Kubernetes cluster that we just created. Just as spinning up the GKE cluster was a series of clicks and filling out a bunch of forms, this is also going to be something similar. To install Trident, what we first need to do is create a Trident provisioner custom resource. And this is what the custom resource definition for the Trident provisioner looks like. Once we have this TRD created, we will then go ahead, create the operator, and then create a Trident provisioner object. This Trident provisioner object will correspond to your Trident installation, and after that, you'll see the real magic happen.
Okay, cool. So let's get this deployed then. So it's just kubectl apply. I always go kubectl instead of shortening it to K as well, just for anybody that's maybe super new. Just so that they know exactly what we're doing and they can follow along at home. So that's created now, and if we do a kubectl get CRDs, we should see our provisioner just created right now. Okay, from that point, I think if we are to deploy the bundle file, yeah?
Mm-hmm. Yep. Okay,
let's just take a quick look at that because there's quite a bit more in the bundle file. So right. I'll just step through the objects really quick. Again, standard Kubernetes YAML file. We use the 3 dashes to separate different objects. And we are creating a service account in the Trident namespace. Actually, let me just create the Trident namespace, okay? Because we are going to be deploying some objects into the Trident namespace. So we will create a service account called Trident operator. Whoops. Then we will create a cluster role, which will give some permissions. And this is role-based access control stuff here. Give some permissions, and then a little bit further down, we will bind that to our Trident operator service account. So those permissions will be bound to this service account up here. Do we have anything? Oh, we do have something else as well. So we will then create a deployment for some more Trident stuff to, I believe, go in the Trident namespace as well. So Bala, you can maybe talk to some of this, but we can run some commands afterwards as well to see exactly what has been deployed once we've done this, and then a pod security policy as well. Do you want to comment on any of this at this point?
So we're looking at standard Kubernetes resources that the operator itself would require. And most of these resources are namespaced and would constitute what the operator would require to make sure that it can watch a Trident installation. We also require a designated cluster role and bind it to the Trident service account because we're looking at an operator that can watch across any namespace in your Kubernetes environment to make sure that Trident installs can be handled, right? Again, all of these are really standard stuff, and you can take a look at these when you're trying to play around with Trident yourself.
Cool. Okay, so let's go ahead and deploy that bundle then. Again, honestly, it's just standard Kubernetes stuff that, you know, if you're new to Kubernetes, I understand it might look a bit complex, but once you're getting your head around Kubernetes in general, this is all just standard stuff. So bundle and a few things deployed there. Okay, so I think at this point, I want to just take a second to let a few things, we'll make sure some of these things are deployed. So now I may forget which things are namespaced and which are not. So if I go kubectl get service accounts, is the service account in the Trident namespace? Do you remember?
I don't think so.
Oh, I can't spell. Know how a 1 looks like an L.
Mm-hmm.
Yeah, it must be namespace. That's fine. So we've got the service account for the Trident operator deployed there. I'm pretty certain that the deployment is namespaced. Yeah, the Trident operator is all deployed there. In fact, I won't go through it all, but all of these different objects here are now deployed to our Kubernetes cluster. So if I just quickly flip back here, A bunch of this stuff is now starting to come together. We're not quite there yet, though. Back to our command line. If we take a look, I think the next thing to deploy will be from this provisioner.yaml here.
We have the operator running. We have the CRD spec defined.
Yep.
The next step would be to create a Trident provisioner. And here's essentially all it has. It's a file with 7 or 8 lines. And you can choose to customize it depending upon whether you need to pull the images from an internal registry, or you want to use IPv6, you have a different kubelet directory, however you want to choose it. For this example, though, this is perfectly acceptable.
And as simple as this file is and the whole config is as well, I think it's maybe worth pointing out that that single CVS backend on our Google Cloud platform can service multiple clusters on the Google Cloud, right? So in fact, I do have multiple clusters running against CVS, and it's working pretty sweet, to be honest. So let's get this applied. It's going to be Trident Provisioner this time. Okay, now that is going to deploy 1 or 2 different things. So if I go kubectl get pod, 8 lines in the file, right? But there's complex machinery going on behind the scenes that's all abstracted from us, actually. But let's see if we can see some of the stuff that's going on. In fact, well, I just caught the last CSI-related set of pods that are currently spinning up. The operator itself is already up. So correct me if I'm wrong here then, Bala, is this going to be the CSI controller, and then is this one instance of the CSI pod per node in my cluster?
Exactly. So we're looking at this Trident provisioner being created, and it has spun up a bunch of pods. And since we're using a 3-node cluster, if you were to take a look at the output with the -o wide, you'd see that these pods are being spun up on any possible node that needs to mount a volume that can be created by Trident. So as a result, we will be having one controller that orchestrates all of the volumes being provisioned, and a node daemon set pod that's created on every single node, so that Trident can attach volumes and perform export policy management and so on.
Cool. So I know the command has wrapped across a couple of lines here, but we have 3 instances of the CSI pod running on 3, these are just the node names here, on 3 different node names like Bala mentioned there. Now,
and the cool thing is, if you were to take a look at the Trident provisioner object itself, if you try to kubectl get tprov-n Trident, and you see the object over here. If you take a look at the output from a describe, you'll be able to follow along the status of the Trident installation in a lot more detail. So we're looking here at the status saying that this object has been processed by the operator automatically, and it has installed Trident for us.
Cool, very good. Okay, so now that that is installed, it's time to build in our Kubernetes cluster the Trident backend. So this will effectively be connecting our Kubernetes cluster to NetApp CVS on the Google Cloud backend. Now, in order to do that, we need the Trident CTL command line utility installed, which I have. Now, all that is it's from that GitHub repo that we mentioned before, github.com/netapp/Trident. Download the latest version of the zipped bundle, and in there is the Trident CTL command line utility. Depending on your operating system, you just copy it into your system path, and like I've typed Trident CTL there, we're good to go. Now, I'm going to put the command on the screen, but I won't, in fact, I will run it, but I'll go, so it's Trident CTL create backend from a file. Looks and feels kind of like Kubernetes almost anyway. From a file,
and that was the intention behind creating Trident CTL too. I mean, we're looking at everything being absorbed by kubectl in the future, but Trident CTL is designed to emulate kubectl. Yep.
Absolutely, and it does a good job of it, I think. And we will deploy this to the Trident namespace. And it won't take very long to do that. In fact, the command's returned already. But let's take a quick look at what that In fact, this file here, backend GCP CVS.json. I've got a dummy file here just protecting some of my own credentials here. But this is effectively what the file looks like. We're telling it to use the Google Cloud Platform CVS CSI driver. We connect it to my Google Cloud project, the region that we're in, connect it to a service account in this project, and then basically some private key information on how to connect it up to our particular accounts, just authorizing that connection between the Trident, the CVS backend on Google Cloud and our Kubernetes cluster. Anything you need to correct me on or explain further there?
Nothing to add, Nigel. This is just the standard information that Trident needs to talk to the GCP CVS service. And this information is all going to be redacted in your backend once you create it. So the only place where this information would reside is in this JSON file. And once you have created that backend, it's all stored as Kubernetes secrets. So nobody can take a look at your sensitive information in any way.
Cool. And all of this information to populate it with your own private keys and things, super easy to get from the Google Cloud Console anyway.
Exactly. Yeah, they're all just parameters that are natively available in your CVS dashboard, so it shouldn't be hard to get that set up at all.
Cool. And again, just to reinforce the point that Trident CTL feels and looks like kubectl, we can just do a get backends in the right namespace and we'll see the same again. Now, right now, this particular backend is not provisioning any volumes, but that is about to change. We want to create a storage class. So this large YAML file here has all of the different Kubernetes objects in that we need. Right at the top, it has the storage class. It has a persistent volume claim object, which will request a 1 terabyte volume via the storage class above. So if I highlight this here, we can see it's going to talk to this storage class. Then we have a service which is just part of our application below. We're going to deploy a really simple MongoDB instance, just a single instance managed by a Kubernetes stateful set based on the latest edition of the Mongo image. We don't need a node selector the way that this works. It's pretty sweet, I've got to say that. So everything that we need in a single app.yaml file. So if we go kubectl apply that app.yaml file, we'll see all of our different objects being deployed. Now let's have a quick watch against the PVC. In fact, no, let's look at the storage class object first. So every Google Kubernetes Engine cluster comes with this standard default storage class, but we've just deployed this one, which will talk to our CVS backend. We should have a PVC created already because this is pretty quick stuff. So it's already created and bound to a persistent volume via that storage class again. So we should be able to see the persistent volume. That's everything that our application needs to be able to use a volume inside of the pod in the stateful set, but that volume is based all the way back on CVS in our Google Cloud. In fact, I need to jump back here real quick just to quickly show you this. So within the stateful set definition here, we are defining a volume, and we're basing that volume on the persistent volume claim that we saw before, which talks to the storage class and provisions storage dynamically on the CVS backend. Within the container, we then mount that volume called PVC Mongo. We mount this volume called volmongo into the container at /data/db. So if you're new to this, there's a lot of things going on, but basically our application is running inside of a container here. Within that container, we are mounting a volume based on this volume we've defined down here, which is based on the persistent volume claim up here. This is good stuff, right? Which is using the storage class up here, which, if I go back to that Trident CTL command, should have provisioned exactly one volume from our backend. So on our cloud backend now, on CVS, we have a volume. So if I go kubectl get pods, our MongoDB application is up and running and it's using that volume. In fact, if I do describe pods, we've only got one running, so I don't need to give the name. And look, under mount/data is mounted in from this volume here. Pretty sweet stuff. Now then, do you want to say anything at this point, Bala, before we jump onto Mongo and just do a little bit of testing?
You hit the nail on the head, Nigel, when you said that it was all in a single file. Everything that we did here was done dynamically. Nothing was set up as a static requirement or requiring a handoff between multiple teams, right? Once Trident is set up, once a backend is created, and you have a storage class that maps to that backend, then the entire power resides at the PaaS level. You can create application deployments, replicas, stateful sets, and have the storage that you need created at runtime. That's the beauty of this. And like you put it, it's really great to see something like this in action where you define everything as code and have it given to you automatically.
Absolutely. Cool. Okay, let's rock and roll with this then. So we have a pod. I better get the name of it actually. In fact, let me just. Okay, so we've got a pod with that name there. So if we kubectl exec with an interactive terminal onto sts mongo 0, and we'll run the bash shell inside of that. Okay, if we just go into Mongo now, oops. Oh yeah, that's up and running. Now, I'm not a Mongo expert and we're not trying to demonstrate MongoDB for you here at all. So, we're not trying to emulate a production or how you would run this in production by any means, okay? But if we'll use the admin database and authenticate to it. I should probably have had this. I'll show you what this is here just real quick actually, but within our YAML file, when we were creating MongoDB, we just set up you would not do it like this in production, okay? Promise me that you won't. Just a quick admin and password. So we're authenticated there. So what we're going to do at this point, right, is we are going to write some dead simple data to MongoDB. And that data is hosted outside of the container on that NetApp CVS volume that we created before. So we will be able to then delete the pod and the container that is running MongoDB. The stateful set which sits above that is clever enough to be able to say, well, I'm supposed to have one MongoDB instance running. Nigel's just deleted one. I better spin up a new one, and it will spin it up, connect it to the same storage backend, and will verify that the data still exists. And we probably won't do this, but you could delete a node or you could delete the node that the pod is running on, and just another way to delete the pod and for us to prove that the data still exists. The whole point is here that the life cycle of the data is decoupled from the actual application. So we've got MongoDB running here, connecting to highly available, high performance NetApp storage on the back end. When we blow the application away, we're not blowing the storage away as well. So any infrastructure failures, maybe one of our nodes fails, maybe our application crashes or something, our data is still safely protected by NetApp on the back end, okay? Anyway, look, I'm waffling, so let's get this command going. Right, so with this command, what we are doing is we're just inserting this data into the document database, basically. So that data is written, and if we do a db.admin, we wrote it to NetApp, and find, there is our data. In fact, if we do, I think it's .pretty, just looks a little bit nicer. So we have written some data to MongoDB, which is stored on the CVS backend, all highly available, all that magic. So if I come out and in fact, I come out of the pod, do a kubectl get pods again. Our pod is running for about almost 10 minutes. Okay, so if we do kubectl delete, pod stateful set mongo 0, delete our pod, okay? Now remember I said that the stateful set is sitting above that pod and it's watching to make sure that we always have one pod of that particular definition running. So if we do the get pods again, we can see that the stateful set has noticed that the pod was deleted or it wasn't there anymore, and it fired up a new one which is already running. So I don't know, 10 seconds or something, and we're back in business, which if we jump back onto that pod, Mongo, and I believe a find is an operation that requires authorization, so we'll just authorize again.
Did you have to switch to the admin
I did,
DB
yeah.
first?
Yeah, thanks for that. So admin DB, not to worry though. Okay, so we are authorized, and now if we do the find operation against admin on the NetApp collection, if this works, we should still see our data in there, which of course we do. So I just want to really quickly summarize here. In fact, let me jump back to the slide to do that. So we have got a Kubernetes cluster in the Google Cloud that has some highly available, high-performance NetApp storage built into it. Cloud Volume Services is what it's called on the Google Cloud, on the cloud. Within our Kubernetes cluster, which we built with special nodes that have the NFS client packages installed, we then installed a load of logic and intelligence to be able to have our Kubernetes cluster seamlessly talk to and leverage the storage on the NetApp backend. Once that was in place, we built a storage class that allowed us to dynamically provision volumes from the backend. Once all of that was in place, we chose to use a MongoDB application and a really simple instance of it as well. Not trying to emulate production here in this demo. Could be any application that you need. The point is, once we were at that point, everything is in place for your native Kubernetes applications to start using that high performance, highly available NetApp storage. So we built a MongoDB app, we logged onto it, we wrote some data to it, we destroyed the pod that was running it, but because the storage is decoupled from the pod and it's highly available on the NetApp backend, destroying that pod did not destroy our data. So as Kubernetes self-healed that pod via the stateful set, reconnected it back to the data, and we were back in business. Now, again, super simple demo, right? But the things I really wanted to get across are that this NetApp CSI implementation, the driver plugin, all of that stuff, super sweet. It's been around for a long time. It's well respected in the industry. It's, you know, it's robust. It's fairly feature rich. It supports multiple different storage backends. I love it the way it's integrated into Kubernetes. But then all of the operators and the custom resources and all that kind of stuff that just make all of this look, smell, and feel like Kubernetes native stuff. It's like when it comes to managing stateful applications and persistent data, is a huge step forward from, you know, where we were a year or two ago. And like I said at the beginning, and I don't know whether you want to say anything on this, and feel free to say anything on any of it, by the way, Bala, really is only the start of like a lot more that is to come from NetApp in the Kubernetes space. Various announcements have already been made, more products, more integrations, more advanced features and things that enterprises and enterprise applications really require are coming just a little bit further down the line. I'd love you to say a few words, Bala.
The example and the experiment that we just did here was the litmus test to prove that persistent storage really is persistent, right? And we have taken a look at some of the simple functionality tests that show how Trident can provision persistent storage. Does a lot more than that. You can clone data sets. You can create snapshots of existing volumes. You can create export policies to regulate access. I mean, the list goes on, and it's all covered in our documentation.
I think it's worth pointing out, Bala, as well, just sorry to cut you off there, but when you download the zip file from the GitHub repo, within the different folder structures in there are already example YAML files for a bunch of the different backends, the ONTAP backend, the SolidFire backend, plus more complex examples of hooking into things like clones and things that you mentioned there. I wanted to point out, we just showed like a really simple demo here, but it's not hard to do more advanced things because of the sample YAML files that are in the repo.
Mm-hmm. The sample input directory contains everything you need to create a backend, depending upon whichever service you're using, a list of different annotations that you can use in your storage class definition or your PVC. And again, it's all really intuitive, simple stuff that's especially all just YAML. There's nothing that you need to do in addition to install or use Trident.
Great. So I'm just going to wrap this now, Bala. We're running a Q&A session at the NetApp booth during KubeCon EU as well. Check the schedule for that, where Bala and I will be online. We'll be taking any questions that you can throw at us. Bala will be answering all of the hard ones, certainly the ones that are particular to the NetApp stuff, but anything, Kubernetes related, persistent data related, I'm more than happy to chime in on as well. We'd love you to join us there. And try and make it as interactive as we possibly can. But I want to wrap, and I'll give you a chance to wrap after me, Bala, just by saying that, what I said at the beginning about any Kubernetes native storage solution requires a solid foundation of a good CSI driver or plugin. And NetApp have got that going in spades already, okay? And I genuinely, and I'm not saying this because I'm here at the NetApp booth or anything. Look, I spent a lot of my life before I was doing containers working in the storage industry. In fact, I wrote a book on storage that was published as well. So this kind of persistent data and stateful applications is genuinely close to my heart. And I felt for the longest time that, it was such a slow progress to get to where we are today. And it took such a long time, but we're here now. The Trident solution now, just call it that for want of a better term at the moment, is solid. But I think that the pace at which we're going to move forward, and this is my opinion, I don't speak for or on behalf of NetApp here, right? But just the vibes that I'm getting and the things that I'm seeing is the foundations are in place and the appetite and the attitude is there to take this much further forward, so that if you are an enterprise looking to use Kubernetes, and it can be on-prem or in the cloud, we've talked about that, great solutions are starting to be here, and even better ones are coming. I'm pretty excited.
And you made a great point there, Nigel. We need solutions that are easy to use, readily available, dynamic, and handle storage provisioning on demand, and make sure that most of the complexity that doesn't need to be surfaced is abstracted. Whether you're somebody who's new to Kubernetes or you're someone who's using Kubernetes at scale, you are definitely going to run into a situation where storage persistence is of utmost importance. And that's where Trident really comes into the picture and shines and maintains its own position. We have customers who are using petabytes of data managed through Trident and across a whole bunch of different deployment scenarios, on-prem, in the cloud, a hybrid multi-cloud scenario, whatever you name it, you have one instance of Trident, a single installation setup guide, and it works just the same as magic. You can get in touch with us on our Slack channel at netapp.io, and netapp.io is where our information on everything that we do with respect to Trident lives. You can find a number of blogs and how-to posts that help you get started with Trident, and the best place to get started with Trident would be our GitHub repository. Our code is available for you to see, and the documentation does a stellar job of helping you walk through installing Trident, creating a backend, creating snapshots, volumes, whatever you may have.
I know I said I wasn't going to say anything else, but I do want to just echo one of the things that you said there, is this really is comprehensive. So not only have NetApp done a sterling job when it comes to the CSI stuff and all of the CRDs and the operator stuff, all of that, that's a given, right? But quite often you'll see projects where they do the code well, but then like the examples and the documentation that's required for mere mortals like most of us to actually go and build it and deploy it and use it in our production applications is often missing. So I do want to give a shout out. The example YAML files are a great place to learn and to start as like a great starting point for you to build your own. And like Bala said, the documentation does a great job as well. So all round in this space, I think, it's kind of hats off to NetApp as to what is done so far. But I'm going to lay down the gauntlet as well and say, I am expecting a lot more in the future, and I'm seeing good signs of that right now. But if NetApp can step up to it with their A game, I really do, for the first time in a long time, think that the future for stateful applications and persistent data is bright on Kubernetes. So exciting times ahead.
There's a lot more where that came from. We're moving from just being able to provision volumes to be able to make app-aware data management decisions. How do you move entire applications, not just the data, but also the deployment, the stateful set, the service, whatever you have, all of those resources between Kubernetes environments, between namespaces. What if you have Kubernetes clusters on-prem and also in the cloud and you want to move stuff around? These are the type of questions that people are asking with respect to data management today. And we have work that's happening in this space, and Project Astra, which is under development and it's going to be available pretty soon, is tackled to do exactly that. So for people who are using Kubernetes at scale or looking to do high performance workloads and mission critical applications, this is something that will get you really excited.
Magic, looking forward to it. And on that note, thanks for joining us here at the NetApp booth. Enjoy the rest of KubeCon. We'd love to chat with you in the live Q&A session. Check the schedule again for that. But aside from that, that's Bala and I signing out. I'm at Nigel Poulton on Twitter if you want to connect with me. Have fun and enjoy the rest of KubeCon.